So what's lockout, tag out? Tag. That's just an extender. I know it's got a name, but what'd you say, Brian? Yeah, it's the way we used to remove all power sources from the system and prevent it from being what? Turn back on. Valve up. Nearly 150 people died because there was a failure to control the energy, in the workplace. These deaths could have been avoided if workers would have took just the time to pull lockout, tag out. And it always amazes me what people will do to get themselves killed just to save a little time, right? Okay, this is what the purpose is, right? Prevents injuries and deaths and results from accidental release of energy. And everybody in the workplace needs to know the lockout procedures for. We're going to look at generic lockout procedures, but what you really need to have, and this should be part of your safety training when you go to work someplace where they go through their lockout and their tag out procedures, right? Everybody okay? Is lockout and tag out the same thing? No. So you can have a tag without a lock, but you should never have a lock without a tag, right? So what are locks? A lock is any device that locks out any electrical or other type of energy. A lock is most often placed on the machinery to turn it off and prevent it from doing what? Starting again. Locks prevent switches from being activated or valves from being turned on. Locks are most often used when machinery needs maintenance or repair. Now what you have to understand is we are troubleshooters. You can't troubleshoot with power off. So there's a lot of situations that we'll do where we have to work with power on, right? You understand? What we're talking about is actually doing literally maintenance, right? Going out there and replacing things, doing some preventive maintenance might require lockout, tag out. If you can't put guards and stuff like that around some system. What is a tag? It's a card, paper, metal. We had paper when I worked at U.S. Steel, a real thick paper though. Now I understand they use metal. They have metal tags they put on their locks. A tag usually indicates who placed the tag, the date it was placed, the name of the workers involved, and the supervisor's name and the equipment being worked on. It depends on what you required. It usually always required. I never worked any place where it didn't require your name. So they know who put it on and who should have the right to do what. Yeah. But you got to look and see, like we carried our tags all the time. They were on our locks. And we always had our name and then the number to our shop. I don't remember putting the boss's names on there, but every place you go, and the minimum would probably be your name, right? You put it on there, it might be the date. Some people might want the reason the tag's on there. So it's hard to say. Tags warn that machinery or equipment has been de-energized so work can be safely performed. Tags should be durable, right? You understand? Durable. So they should be made out of some material they don't tear we're going to use regular copy machine paper in here because as many tags as we go through, we couldn't afford to keep them. So we just run them off on a regular printer over there and fold them up. But you don't use rubber bands to put them on there. Accidents can be prevented. Many employees are killed or injured each year. We said 150, right? when they were working on machinery and power is accidentally restored. We had a guy, we had a guy when I worked out there, didn't lock out and tag out, and he went out there and was working on a big old roller with a torque wrench that must have been that big. I saw some equipment out at, or tools out at US Steel I never envisioned that I would see was that big. And he was out there, got that thing, was pulling on it, and they changed shifts. And somebody had, and the standard thing was to come in and jog, which means move. And he had that thing and it beat him to death. I know it broke at least one of his arms and stuff. But whose fault was it? It was his. It wasn't the person that jogged. That was standard procedure. You know, there was a video, I don't know if I still got it, I need to look at it, where they had a lift at a bottle plant where there was some broken glass under the lift when they was lifting it up to different layers with a bunch of bottles up. And they told the guy out there, go in there and clean that up. He went out there and was under that thing, cleaning it up, and guess what they did? They came down with it. So, but he was a new employee, so undoubtedly they didn't go through any safety procedures or anything like that. And the guy at the who makes the tuna, it might have been Starkist, I don't know, but he was in there cleaning out one of the big ovens. And he didn't lock and tag it out, didn't do it. They came in and they would fill it in from the top, and they closed that big old oven and filled it full of fish and cooked it. So, you can probably look that up on the internet. Instructors to clean or asphalt mixing machine. And for example, a worker is instructed to clean asphalt mixing machine while he's in the process of changing the paddles. Another worker bumps the switch on the mixer door, closing, hits the worker in the head, and it kills him. But you got, I think I tell the story about when I worked at US Steel, number 8 blast furnace. There was a guy. It was what they call a continuous pressure. It was pressurized furnace. So they fed the top of the furnace at a big conveyor belt going up to the top of the furnace. And what they'd do is they'd open up one hopper door, they'd open up one door and it would fall down, and then they'd close it, and they'd open the bottom one and it would fall down into the furnace, you know, when it was making iron. And they was in there working on the dang thing, and they locked out and tagged out the top door, but guess what they did? They didn't lock out and tag out the bottom door. And they was in there, guy was in there working, and they had the actuator. I don't remember if it seemed like it was hydraulics. And wanted to go down there and push in the relay, like I showed y'all over there. You know, these relays have manual overrides on them for obvious reasons, because you might need to get things out of the way. You know, you might. And they went in, guy went down there and pushed in the wrong relay. And they brought up the bottom door or the top door. I can't remember, and killed him. It was just because they didn't lock out all the power sources of everything that was available, and that's what you got to remember to do. So, every industry relies on energy to power equipment that manufactures goods. Energy comes in many forms, and that's what we got to understand. So what you got to do is you got to lock out all power energy sources that's feeding that thing, right? So what could we end up with? We could have electrical, chemical, thermal, hydraulic, pneumatic, and even mechanical. You need to lock out all energy sources, right? Okay. Like some robots, you know, you get guys out there and they have the robot up there. And they'll pull one of the motors off, and the robot's up here, and they pull the motor out. What do they do? It just falls down. Machines or equipment needs to service or maintain. This energy must be isolated so authorized personnel can safely perform work. The goal of lockout tagout procedures is to protect workers. Another goal is to prevent energy from accidentally being released while machines and equipment are being maintained or serviced. Now there are some most of the stuff you run into residential, we don't lock out tag outright. But most of the time, but you're supposed to have disconnects inside of the equipment that you're working on. Inside your house, there's a lot of leeway because you probably only got one panel box, right? And then you could be in there. And I've never done this, but it makes sense to even put a tag on a breaker and say, well, on a breaker in your house. You're in there like replacing wall outlets. I got a couple in my house that needs to replace. So over time, wall outlets wear out. And if you got one where a cord won't stay in it, it pulls out real easy. Guess what? It needs to be replaced. And wall outlets shouldn't get hot. Usually, if they get hot, that means it's time to replace them too, right? You understand? Because that means they got resistance in there. We understand if you put current through resistance, you get heat, right? You understand? So we was in my wife was in the kitchen cooking the other day, and she had a griddle going, an air fryer, something else going, and all of a sudden they stopped working, and a wall outlet over on the right hand side with nothing plugged into it started arcing. Got hot real fast. Got so hot it actually melted the plug in there. People don't understand that, and the way the house is run is all your plugs feed through other plugs. If most electricians take a shortcut, so the way the plugs are designed, I wish I had one over here. Everybody's seen a wall plug. Well, it's a parallel circuit, but it's a parallel circuit, but the way the things work is if you ever go out and buy them, first of all, I would never recommend doing this. Is if you look at it from the back, they got 2 screws on each side, and then you got one that's silver, and then the other one is brass. It's PR. So much stuff brass. Huh? Yeah, my brain would do. PR. Thank you. I was trying to spell bass. But what they got, you ever had a dead moment? They've got these little compression things in the back where you can come up and just strip the wire and push them in there. Don't ever use those. That's what they did when they wired my house, and I've had to replace every outlet. But what they'll do is, even though we have a parallel circuit, what they'll do is they'll bring in on the brass side, this is where the black wire should go, and on the silver side, this is where the white wire should go. Well, what they do is they'll bring one of your black ones into the top, and they have a metal connector that goes between the two, and then they'll feed the plug from the next screw down. So you'll see 4 wires back there, right? You understand? So what was happening is that the plug that was arcing was feeding those other plugs, and it got a little bit of resistance in there, and it was pulling a lot of current. And as soon as it got that, it got real hot, and it's copper, and copper oxidizes when it gets hot, which means added more resistance, and it was still trying to pull that current, and it started arcing and actually burned through, and the other appliances went out. So of course I went out there and kicked the circuit breaker, and I was in there working on it, right? And you never think about that, but if you got people in your house and all of a sudden the power goes out and you're up there working on something, and the power goes out and you got other people somewhere else, what's the first thing they're gonna do? They're gonna go to the breaker panel. They're gonna find one that you popped, right? And what they're gonna do? Flip it back on. So, and also, guys, another thing, this guide, I don't know if it says it. We'll look at that. Is you always verify that the power is removed, right? You understand? So how would we verify that your electrical power is actually removed? Yeah, you take your voltmeter. So you go up there, you lock out, tag out, you go where you're working, you take your voltmeter and you put it on there and make sure that. How do you verify other energy sources? And the problem we have with other energy sources is they store, right? You understand that? So like pneumatics stores energy. Hydraulics could. Some companies especially if it's a big hydraulic system. Y'all know what hydraulics is, right? What's hydraulic? Well, it's not. I always thought that a fluid was liquids, and that's not true. A fluid is anything that has no fixed shape, it moves easily, and it takes the shape of what it occupies. That is a fluid. So a fluid can either be gas or it could be liquids. It could be powder like flour could be considered a what? A fluid, right? You understand? So fluids, and before I taught fluid power, I thought fluids were what? Were liquids, but they're not. So we have two fluid powers that we use. We have pneumatics and we have hydraulics. So what's the difference? Now this is specified. So hydraulics is when we create a force with liquids, right? You understand? And pneumatics is when we create a force with a gas. And of course the predominant gas is air, which is a mixture of gases. So how do you assume that? Well, you think when you turn off a the difference between hydraulics and pneumatics is hydraulics creates pressure as soon as you try to use it, because we consider liquids to be uncompressible, which is not exactly true, but they compress so little that we couldn't even measure. So they're instantaneous. Gases, though, don't create pressure until you compress them, right? You understand? So gases, we have to compress them, and we usually store them in a tank, right? Y'all been around compressors before. And that's stored energy. Well, a lot of times in a big hydraulic system, they'll use what they call an accumulator. And what they do is they'll put a big old weight or a big old spring in there, and then when they turn it on, they'll fill that thing up with hydraulic fluid. And what it does is it smooths the system out for one thing, but it also allows them to maintain pressure if power fails. Because a lot of times you have things that if power fails, they're going to fall, right? You understand? So they like to hold those things up until they can figure out. So these are called accumulators. So just because you have a hydraulic system don't mean it's got what? They don't have stored pressure. So once you verify that nothing's going to fall and you strap things up and everything on a hydraulic system, then what you would do is you would go in there and drain that accumulator, right? You understand that? To relieve the pressure. Pneumatics is pretty easy. You could literally do what? Pneumatics have a tendency to collect the moisture, because what we're doing is we're taking a gas that only can hold so much water per cubic foot, and then we're reducing the amount of cubic feet. And what does it do with the water? It just releases it. Plus, we have another situation where when we compress it, it heats it up, right? You understand that? And then when it cools down, it does what? It collects moisture. So we have a big problem with moisture getting into a pneumatic system. So any good pneumatic system, you'll see drains every once in a while where you can do what? You can drain it. Well, that's a good place you can do what? Release pressure, right? Just about any, we call it a service unit, has a drain plug on the bottom. You could do that to do what? Release the pressure, right? So you need to do pneumatics. You have to our lockouts for our pneumatic system. You hear it when you push it in; it automatically drains the system. But what you need to do is you need to have like a pressure gauge out there past your lockout, so you can do what? You can verify when you lock it out that pressure gauge is reading what? 0 psi. Are we okay? Lockout tagout procedures may only be performed by authorized employees who have received proper training. That's what we're doing right now. Authorized employees are trained to recognize the types of hazards, energy sources in the workplace, and know how to isolate and control that energy. Right? Okay? 7 steps. The process of lockout tagout is most successful when 7 simple steps are followed. So what's the first one? Proper planning. Second one is very, very important. Is to do what? Let everybody know. All affected employees know. So I think OSHA calls it affected employees. Everybody that's going to be affected by this, right, should know it. Well, you go around and you tell people. If you got a PA system, they might announce it over the PA system, you know, that we're going to lock this thing out. But normally you know where you're at, and all your operators and everybody are there. But anybody that's supposedly affected by you locking that thing out, you're supposed to do it. Let them know. Shutdown of operational controls. So you need to understand how to properly shut down a system. You just can't a lot of times just go out there and kill power, because like I said, you have to park things. You know, you have to put things down where they're not going to collapse. You might have to override a lift and lower it down so it don't do what? Fall down when you cut off the pneumatic pressure. Isolate all energy sources. It don't say just electric, it says what? All energy sources. Lockout, tagout of isolated devices, release all stored energy or residual energy, right, which usually comes with hydraulic or pneumatic system. But it could be something lifted up in the air. That would also be what? Stored energy, right? You might need to lower it down before you kill power if you can. And then the 7th step is to always what? Verify the isolation. Because you have the electrical disconnect. Sometimes those things get stuck. When you clip them, they don't actually disconnect. A couple will leave. So, or you might do the wrong one, right? You understand? You might think you're locking out, but you're actually locking out something else. So always verify what you do. Proper planning is key to success of any lockout tagout procedures. Authorized personnel must consult with written procedures. U.S. still call them SJP, safe job procedures, that we had to read all the time. We didn't have any real formal safety training. Basically, what they did is they just put you with somebody while you were what they call a starter rate, and so you were always with somebody. And for 6 months, and after 6 months, you went to what they call standard. You had no official safety training. That has really, really changed a lot, guys. So just about any manufacturer that you go to work with, before they even put you out on the floor, what are they going to do? They're going to give you all the safety training. Now go over there and work with so and so. You out there, he says, "Don't touch that right there." There's a guy we got that does OSHA training, and when he talks about this kind of stuff, it reminds me so much of what we've been through when I was back in the, I'm not going to say good old days. So written procedure, proper personnel to determine the types of magnitude of energy involved, the hazards of the energy that must be controlled, and how to control that. Everybody okay? Lockout, tagout procedures. A proper planning helps authorized personnel answer important questions about the system to be worked in. What equipment is needed besides the lock? Are there any hazards, substance to needs? We'd go out and work on our airplanes, and these were big old airplanes, and we wouldn't park close to them. They were way out, and it was really bad. You get out there, walk all the way out there to the airplane, and you realize you didn't have anything that you needed. And we never locked out or tagged out anything. We had one of our guys out there. He was replacing a relay we had the airplanes I worked on, the P-3 Orions, big old sub chasers, big airplanes, 4-engine turboprops. He was back there, and they had a load center. We call it the load center. It was a thing that had a door on it. And you could open it up and go in there, and that's where all the relays and all we call them the regulators for all the generators and everything was in there. And he was back in there replacing a relay. And then somebody came in and didn't even see we called him Tex. His name was Michael, but he was from Texas, so everybody called him Tex. And, I could tell you some funny stories about Mike. He's really, really good. He was back in there working on that panel, and we didn't do lockout tagout back then. And somebody came in and threw power on the airplane. And Tex, he was the neatest guy. When he tried to do something real close, it was really interesting in watching him solder. His hands would start shaking like this. But he would time himself, and he could solder just about as good as anybody. He'd hit the solder at the same time. But it's inside that supervisory panel, and he had a screwdriver down through there. I think the voltage was 240, the 3-phase power we had. And he's trying to get his screwdriver out between those things. And he brought his screwdriver back in there, and it was all burned to pieces but he didn't get shot. And same guy too. He was up there, in the plane, the back of the tail, or we call the vertical stabilizer. There was a navigation light, a little white light way back up there on this tail, way up there. It was it was way up there. And Mike would get up there and he'd jack his big old, we called it a B4 stand, but one of these stands you could jack up. And Mike would straddle that thing like a horse. And he was up there working on that thing, and he had it all taken apart. And he was down inside that, and guess what somebody did? They turned fire on the plane. And, yeah, he got shocked then. But it was only 24 volts DC, but it did shock him. But it was funny. Anyway. But Mike, good guy. So, but there was no way to lock out. There was no way to lock the airplane out. You could not lock power out on that airplane. In fact, it had an auxiliary power unit on it. It had its own generator that you could start off a battery. It had a jet engine in the belly that you could actually start the jet engine off a battery. And they would fire that thing up, and it had a 60 kVA generator on it. And so we didn't have to hook up a power card on our airplanes to work on them. And they could start the big jet engines out there by bleeding air off the APU. So it's neat. I'll have to show you the plane. They're still flying it. They're trying to phase it out though. Are there any hazardous substances that need to be drained? Should protective equipment be worn? Should personal protective equipment, right, or PPE be worn? Could energy accumulate again while work is being performed? How many locks are needed for the job? So you need to have that right off the bat, right? You understand? Because if you got to lock out all energy sources, and that's something that we didn't do when I worked at US Steel. Everybody carried one lock. And all we locked out was the electrical. But things have really, really changed since then. So now you might need, 3 or 4 locks, to lock out the electrical, to lock out the pneumatic, to lock out hydraulic. Notify all affected personnel. All affected personnel must be notified if this step of the lockout tagout is not performed. Procedures may not be effective. It's important that affected personnel understand the situations and do not participate or interfere with the process, right? I understand that. Step 3, turning off the machines at the operating control. Shutting down the machine at the operating control does not bring the machine to a zero energy state. Operation could still occur if there was any stored energy left in the system, if the equipment has more than one energy source. We've talked about that, right? Okay. After shutting down of operating controls is complete, all energy sources must be isolated as close to the source as possible. This means taking steps to make sure energy has no way to reach the machines or equipment. Many energy, I can read this as good as I can. Many energy isolating devices are used depending on the type of energy to be isolated. Circuit breakers, disconnect switches. Y'all know what a disconnect is, right? What that is? Right, okay. Yeah, disconnect. So y'all know what disconnects are now, right? And that's this is usually where we try to lock them out at, is the actual disconnect. Line valves, blocks, blanks, and blinds. I don't know what they mean by those guys. Anybody know? Blanks or blinds? Got me. We could probably, if you look up blinds, they'll probably bring up Venetian blinds that you see at your house. As each energy source is isolated, a lock must be applied to the energy isolating device by an authorized employee to prevent it from being locked. Operated. As each energy source is isolated and locked, a tag must be applied to the energy isolating device to the lockout. You're supposed to put it on the lock itself, right? You understand that? By the authorized employees. Tags are important because they warn others not to move energy isolating devices from the off position. When tags are used, they must include the name of the employee applying the tag. From what I understand, U.S. Steel actually put a number on there that you could call and get it on a brass tag. I don't think they had the name. I'm not sure, but are we okay? And of course, this varies right here. I think we did have we had different supervisors, but I think what we had is we had our shop number. So if you call the shop and you would get a supervisor during the day, at nights there was no supervisor around. We worked independently at night. Equipment being worked on, we didn't put that either, so I don't know what they require. Like I said, every company might have different specifications. You know, you might only use the tag once. But we really, really need to have a way of identifying who put that tag on there, right? You understand? And never interfere with equipment or machinery that is tagged. Now notice here they say tag. They don't say what? Lock. And what we'll find out, guys, is you're going to run into some situations where you cannot lock out. You can turn it off, but you can't do what? Lock it out. And so that situation, like at my house, what I should do is just put a tag on the breaker and say, don't turn it on, because circuit breakers at your house can't be what? Locked out, which could cause a problem, especially if you got multiple people living in your house. I was joking because my grandson, he moves between our house. He'll come in our house and he'll stay a couple of months, and then he'll go back home and stay a couple of months. So he's at our house right now. So, if you find a tag lying on the floor, contact your supervisor immediately, because that means what? Well, something that came from somewhere, right? Yeah, y'all understand. And we need to identify where the tag came from. I guess if you're the supervisor, you don't have to contact anybody. Release all stored energy or residual energy. We understand that now, right? You understand, to bring it to a zero state. So all stored energy. We okay? Any questions there? Release all stored. Let's say this is still many methods exist for releasing leftover. Let's see. Opening drains, relieving system pressure, blocking things, right? You understand that blocking would be if you've got something that's going to fall when you remove that store energy, then you need to block it up, right? Or put it up so it can rest on something, right? You see, understand what we're talking about? Bleeding lines, leaving vents open or cycling the system. I've seen that happen too, where they'll go out there and they'll push in the solenoids and just cycle the system until it don't do what? It don't work anymore. The final step before maintenance or servicing can be performed as verification. So we understand this, right? That's the thing you should do. Lock out, tag out, bleed all residual energy, right? You understand? Now, we talked about and I've mentioned this, haven't we? We talked about hydraulic pressure, pneumatic pressure, but something that's what? Up in the air, right? That might do what? That's stored energy. It's sitting up there ready to do what? Fall. You need to verify this stuff, right? Are we okay? Special situations, this is what we're talking about. Special situations may sometimes call for different procedures to be followed than those already mentioned. No matter what situation, it is important that you respect the potential hazard of energy you work with. Right? We're okay? Some machines may not be locked out. So we just talked about, my house. I can't do that. By the way, we'll show you our lockout kit. We call them plug-in cord devices, where you actually got something plugged in, right? We have lockouts where you can actually put the plug inside a case that prevents them from doing plugging them in. So that's tags must be used in these cases. So, but you're going to run into situations. In big industry, it would surprise me. Other situations, if you're in a commercial application where they might not have a lockout capability, but they should have the ability to do what? But even my disconnect for my air conditioner, it's inside. So normally, if the disconnect is inside, I forgot what the rules go. Within sight, there are some situations where you don't have to lock and tag because the disconnect and the device you're working on are right there together, right? You understand? And you got a visual side of the lock, or still, even if you get into the situation where you can't lock out, then you still need to do what? Tag out, right? Never interfere with a piece of equipment or a machine that is tagged. Some repetitive routines, tasks may not require a lockout tagout procedure, and the proper safeguards are in place. Sometimes these safeguards get in the way, and what will people do? They'll take them off. If these things have got a way of being taken off, somebody's going to do it. Sometimes tasks such as jamming, lubricating, or cleaning may be done if the operator uses the proper tools and does not bypass the machine safeguard.
So on my job, it was a night man there. We used to go around and grease out the pits. Sometimes it's like, don't worry about locking it out or tagging it out. Go ahead and grease it.
Well, sometimes you can, but it should have some type of guard. If it's got anything in motion or anything like that, it should have some guard to keep you from getting into it. Yeah. So, but you have people, they'll come out there and they'll get it jammed, and they'll come back and, they might lock out and tag out, and then they pull the guard off, and then they don't do what? Then they don't put the dang thing back on. So anytime you got any machinery that's in motion that you could get caught up in, then it should have some type of safeguard on it. Did you have safeguards? Yeah. So they're right. So you do some type of lubrication. As long as the lubricating fit is out where you can get to it, and they got a safeguard on there, that's fine. And they're talking about clean unjamming. So if there's a safe way that you got a tool that you can get in there and get the jam out without getting your hands in there, then that's some situations that can work. Cleaning, DC Motors has we call it a commutator, but when the motor spins, it's actually switching the magnetic field on the motor itself to keep it spinning. Well, after a while, and it's got brushes riding up against it, and after a while, it gets dirty. Well, what we used to do is we had a little, kind of like it was a little grind, it was a little abrasive block that we had on a plastic stick that we would open up the side panel, and the motor had to be running. You just put it down there and move it across the commutator. Well, you wasn't in it, right? You understand? And we did that. There's no way you could do that, burnishing the commutator without the motor running. So there are some situations where you run into that, but normally we're going to have safeguards and stuff like that that's in place. And we got a motor over there in motor control where they pull the panels off, and they did what? They left them off, and then the commutator actually burned it up. So now all that garbage in the manufacturing could get down inside the motor, and it's all good. The machines need to be energized to test or position it. Locks and tags may be temporarily removed from the energy isolating device. We've had this before. You turn it out, you isolate it, you get out there and realize there's something you can't get to with the position that the device is in. So what we had to do is go do what? Re-energize it, move it a little bit, and then come back and do it that way. So there should be clean of all this. Gets you to, what you need to do before you throw power on that thing. If you got all these tools and everything, what you should do before you put power is do what? Get all your tools out and get them out of the way before the tags are removed. After the product is complete, all systems must be energized and lock the tag and reapply. So this is if you have to reposition it, right? Most of the devices out at U.S. Steel, and I don't think I brought up my camera. So these are our locks. They have to be keyed locks. And of course, what we've done, every lock has a number on it, and every key has a number on it. Yeah, so that way we don't mess up. And of course, this comes with 2 keys. If the lock comes with 2 keys, you're responsible for both of them, right? You understand that? And I think the ones they use out at U.S. Steel now only have 1 key. If you lose your key, you get another lock. You get another lock. You get another lock. Now, what we have is, if you saw over there on the robot, it only had 1 lock. Well, if you got 5 people working on there, then 5 people should put 1. So every person working on the system, you don't depend on other people's lock. Everybody that's working on the system needs to put a lock. You come over here, and you never use all 6 of these. You come up and use 5 of them, and then you leave 1 blank. And why is that? In case somebody else comes along and you've used all the locks. So we could come in and we could put another one of these where down here, and then we get 5 more. That makes sense? So you should never use these 6. If you come up here and you need another one, you need to get another one of these extenders and do what? Clamp it up here. And that way you're always ready if somebody else needs to come up and do what? Work on it too. Of course, this is a pretty standard tag. We do ours in pencil, so we can do what? Erase them, And this one we can't use anymore because it's been tore. To protect workers repairing the machinery. This is where you're supposed to put your what? Name. It says signed by. Normally we print on here because I've seen some signatures like Donald Trump's. Y'all see the signatures? And of course, this has the date. It depends on the tag. So that's the only information back here. But then we've also got this on the back where you can come up and you put just anything you want from there, right? But the minimum that's required is what? Your name, right? You understand? Are we okay? And usually, who can remove the tag when it's been put on it? Only the person that closed the lock, right? That makes sense. But what if something happens to you? By every means possible, they're supposed to try to contact you, right? But then again, if they can't contact you, then every company has a procedure they must follow to remove the lock when you're not there. I don't think this thing says that. Every company that I ever worked at had a procedure that they could follow to try to remove the lock. That's what you try to do. I don't know. Every one of them's got procedures, but what they had to do is they had to exhaust every means possible to try to contact the person that put the lock on that. And now then it would be up to them to decide exactly like I said, every company that I worked at would come up and try to figure that out. And it usually out of U.S. Steel, it had to be our supervisor that removed the lock. It couldn't be any supervisor. It had to be one of the supervisors out of our electronics department. But like I said, that's something that you'll find out. An alternative example to a group lockout situation is to use a lockbox. A lockbox is most often used during the shift change in workers when all employees put the keys in the lockbox, an isolated device. This box is then locked with a departmental lock by the person assigned to oversee the lockbox. We had a lockbox at our shop, and the supervisors were the only ones that had the key to the lockbox. So that meant if they couldn't contact you, they didn't have to cut your lock off. They could still pull the key out of the box. Contractors, outside contractors may have lockout tagout procedures that are different from your facility. Before any work is done, both the employers and contractors must coordinate the procedures. The contractor's procedure must be safe as those established at the facility. And of course, when I worked out there, basically the contractors had to do our procedures. They had to follow our procedures. A system being worked on must remain locked out during a shift of personnel change. The personnel leaving the job site should not remove his or her lock until the arriving workers has locked out with their own lock. As long as I worked at USD, I worked out there about 4 years. I never remember this situation ever happening. Normally what they did, if we had something really going on that was heavy, they would just hold you over until you finished the job. And so we never actually swapped out that I ever remember. When maintenance and servicing is completed, steps must be taken to ensure the safety of others before locks and tags are removed. Notify all employees in the area before locks and tags are removed. Clear away any tools and other items from machines and equipment and reattach guards. That's where we get in trouble. People will pull those guards off for maintenance, and then they won't put them back on, or they lose the bolts and they just set them back up there, and won't go back and take the time to go find new bolts or anything like that. Follow procedures to remove locks and tags. So what would you think we would do if we're going to remove a lock and tag? First of all, it makes sense. We make sure everybody in the area knows what. Figuring to power this baby back up, right? You understand? You need to know the procedure. There might be a procedure that you have to follow to power it back up. You might have to turn on the pneumatics before you do the electric. You might have to do this before you do that, right? If you've got anything out there blocked up to keep it from falling, you need to go out there and see what needs to be done. Can you remove the blocks or what? Do you have to put pressure on it and then move the device up before you can remove blocks and stuff? 63% of workers injured by releasing of hazard injured were production workers that were not authorized to perform lockout tagout procedures to maintain the service. 63% of people just. So what do you need to do? First of all, you need to notify everybody if you're going to remove your lock. Make sure everybody knows you're fixing to power this thing up, right? Clean up your mess. Don't leave any tools or anything out. Go ahead and clean up your mess. Put all your safeguards that you had removed back into place, right? Try to follow up, try to figure out or make sure you follow a correct go out. Once you're ready, go out and remove your tags, right? You understand? Remove your locks, right? You might not be able to do anything now because there might be other people out there working. Normally what we would do is we would have to hang around since we were basically the electronics, a lot of times what we had to do, we'd have to hang around until everybody got through with their job, because we were usually the person that checked out, especially if it was an automated system. We were the guys that usually had to come in and check out to make sure it works. You might have your operator on hand, or get your operators back out there to do to start up the system in the right area. That's usually what we did, because they usually hang around because they were the ones that actually used put the system back in the way it was supposed to be. So, okay, guys, I believe that's it. Each lock and tagout device must be removed from the energy isolating device by the employer who applied the device. If not available, the device may be removed under the direction of the employer, provided that specific procedures and training for such removal has been developed, documented, incorporated in the employer's energy control plan. So there's a lot of paperwork. Usually now it takes a lot of signatures. It's just to go out and make sure everybody that's in the loop takes care of that before they move the lock. But you can understand there are situations where you have to do that. Our planes had locks on the door, and to prevent people from carrying the locks out to come in the main cabin door. The P-3 is a big plane. They put them on sticks about this long. And, I carried one of them home. I don't know why I did. I had it stuck in my back pocket. And when they started looking for the key, you're supposed to check them in and check them out. They realized it wasn't there. Of course, they called me and I had to come back on base and give them their key back. But you see those commercials where they have the bathroom keys and they're on big old like rims for cars. Huh? I know they do, but it's some movie where they give the key out and it's actually got a chain on it. And it's got a rim, a tire rim on it, and then dragging it over to unlock the door. So our planes literally had the main cabin door. It only had one cabin door, but it was a lot like the cabin doors on most airplanes, where they open in And they had key locks on them, so you had to have the key lock. And so when you left, you had to lock the plane door before you left, and then unlock it when you got there. Oh, okay, so it doesn't mean nobody can remove the lock, right? But you are the one that's supposed to move the lock, but certain things happen. You might not be there to unlock it. You might be, you might put your lock on there, forget to take it off, go down to Florida somewhere. We had our planes were nuclear capable. So they had nuclear loading teams where they would practice loading nuclear bombs. And they never told them that they were real or unreal, but they had the mock-ups that they used to put up in the bomb bays. They had one of the guys that was on one of the teams was hand gliding or might have been skiing down in Colorado somewhere and broke his leg. And he couldn't drive his car back because it was a stray ship. And they flew one of our airplanes down there and picked this guy up to bring him back because he was on one of these nuclear load teams. And they trained, and they picked, it wasn't just the ordnance people, they picked people out of different shops to come in and be qualified to load the nuclear bombs. That have the planes way off. Of course, if a nuclear bomb went off, it would have killed all of us anyway. Yeah, some of the bombs that we would drop on submarines, those were nuclear bombs. They'd blow the submarines to bits. The primary purpose of the P-3, it was an ASW, anti-submarine warplane. And its primary mission was to seek and destroy submarines. And it could do it too. Are we okay? All right, guys, y'all take a break.